Hello everybody! Welcome to funwithphysics.com. I'm Ben, and let's jump right into some experiments. If this is your first time on Fun with Physics, I'm going to show you how to do some experiments. I'm going to film them out for you, but if you don't want to see my face, instructions will be down below the video. Mom always said I had a face for radio. Now today we're going to be talking about everybody's favorite little fidget toy. It was one of the biggest trends of 2017 and probably died just about as fast as Gangnam Style did. Today we're talking about the fidget spinner. With this fidget spinner we're going to be able to show off a very cool physical property of spinning objects, and it deals with their angular momentum and their torque. So the first step is we're going to have to get rid of these little caps off of the fidget spinner. Don't play with knives, kids. Now, once you remove the caps from the fidget spinner, you're going to want to find a pen. And you want to find a pen that's going to be snug in the fidget spinner. And you're going to want to cut it to about ½ inch on either side of the fidget spinner when it's sitting inside of it. Once you get your pen cut, you're going to want to put it through the fidget spinner. And now what you got to do is find a way to keep it from sliding side to side, because that's no good. I'm going to use duct tape because I got an abundance of it. And I'm going to tape either side, but make sure that it still has the free ability to spin. And there we go. Now that's not going to be moving side to side, which is perfect. The final step is we're going to need a string of some sorts. I just use sewing thread and just wrap it around here and tie it off, or maybe tape it down, and make sure, leave a good few inches above the fidget spinner. And now we're all done. Isn't it beautiful? Now, for this experiment, all we got to do is just wrap it around your finger a little ways and just drop it. And just drop it. Well, maybe you know what? Let's just give this a spin, and oh, there we go. Isn't that magical? Well, this seems kind of odd. Why would it just be staying upright now just because it's spinning? Why doesn't it just fall over like it normally does? Well, the answer lies in torque. When you're looking at the fidget spinner from the side, you can see that as you drop it, it appears to rotate, which it is rotating. And this means that there is a torque on the system as it rotates downwards. And this torque you can visualize as a force pushing this way on top to push it down like that, as well as a force pushing inwards on the bottom like that, which is why it rotates. Now, the fidget spinner is always going to be feeling that gravitational torque, as in the force pushing this way and the force pushing that way. But when it's spinning, it won't feel the full effect of that force until it's 90 degrees away in rotation, which means it will start feeling a force this way on the back, which makes it rotate just like that. Now the same can be said about the force pushing that way on the top, because you see, as it rotates, it won't feel it till 90 degrees later, pointing that way, so it's going to push it that way. So it's in the same rotation as the one on the bottom, which would be that way again. And that's why it stays upright. It's not breaking any laws of gravity, it's just essentially redirecting that torque so that it turns into a precession as opposed to a rotation over. And now you know a new way of using your fidget spinner, which I personally think is the best way to use it, because you get to learn, you get to do some science. Who doesn't love some good science? And that will do it for today's experiment. If you're not currently on funwithphysics.com watching this, you should head on over there. There's a lot more experiments like these, lots of fun to be had. And as always, have fun with physics. I'm just going to hypnotize you. You're going to have fun with physics. You don't have a choice here. It's an order.